Mobileye 作为自动驾驶和 ADAS 的全球领导者，一直致力于通过创新的计算机视觉和人工智能技术，推动道路安全的变革。如今呢 ，Mobileye 在全球范围内与众多车企开展了深度合作，不仅帮助他们提升市场竞争力，还支持车企在快速发展的自动驾驶市场中应对多样化的挑战。今天我们会和 Mobileye 的创始人、总裁兼首席执行官 Amnon Shashua 教授有一个深度对话，了解 Mobileye 在全球和中国市场的战略布局，如何帮助中国车企实现成本与安全的平衡，并顺利应对海外市场环境的挑战。同时，我们也将讨论 Mobileye 在未来10年的技术发展路线，以及如何更高效地利用 AI 等新技术，不断引领智能驾驶领域的创新和自动驾驶的实践。期待本次对话能为您带来更多的关于自动驾驶行业前沿技术与市场趋势的洞见。
You are an entrepreneur or you are a professor?
Both.
Both. Which job you like best?
Both.
That's different.
It's different, you know, as a professor, you take a narrow subject and you go deep. So the kind of impact that you can have is limited. As an entrepreneur, you can both go deep but go very wide. So you can have a much bigger impact on society.
Yeah.
So the combination of two is what makes it really exciting. Being able to go deep and also make a big impact.
Yeah. I noticed that actually you create a lot of companies. Mobileye is one of them.
That's right.
Can you give us a brief introduction of the core business of Mobileye?
So Mobileye is a camera processing company. That's our DNA. Being able to take camera input, video input, and interpret the scene and create functions that started with driving assist, functions that would warn you against a collision, would apply the brakes before a collision, would warn you about pedestrians, about traffic signs, traffic lights. Mm-hmm. So understanding the scene and taking actions to mitigate or prevent accidents. This is how we started. And this is a big part of our revenue. We designed a chip, very efficient chip that we called IQ. Now we are in the 6th generation of the chip. And then over the years, we started to expand. The next step up is a system that takes multiple cameras. The first launch, we call it supervision. The first launch was in China with the Zeekr 001 and 009 and also a Polestar 4, which interprets the scene 360 degree and allows hands-off driving. The driver is still responsible, so the driver needs to focus on the road and not do something else, but the car has the ability to drive hands-off. This is our current stage. So we have first generation was launched in China, more than 300,000 vehicles, gave us a lot of experience in bringing something so complicated into volume production. Our second generation is coming out next year with Audi and Porsche, entire Volkswagen group. With our IQ6 chips, we have 10 times more compute. We can add more AI technology into the system and provide a more robust and more availability of the system. Our vision goes way beyond that. We believe that in order to create something that is a revolution in transportation, you need to move from an eyes-on where the driver needs to pay attention to an eyes-off system where the driver can legally do something else, not pay attention to the road. We call that chauffeur. The first production is coming out with Audi early 2027. It will be on highways, and it's designed to be a very useful system in the sense that it will drive up to 130 kilometers per hour. It will change lanes autonomously, follow a route autonomously, and allow you to legally do something else.
It's already L3 or nearly
so
L4?
So this is L3, L4 kind of. You still need to have someone behind the steering wheel, but you can do something else. You don't need to pay attention. You can work on your smartphone, for example.
Hands off, eyes off.
Hands off, eyes off. Right? Now, Why is this a revolution? Because once you allow the driver to have eyes off on a long stretch of driving, right? So most of our driving is on highways, right? If you look at, say, the US, you take a trip from San Francisco to Los Angeles. It's a 5-hour trip.
Long.
1 hour is in city, and then 4 hours is on highways. So let's assume that out of those 5 hours, 4 hours you can work.
Yeah, it saves a lot of time.
This is a huge value proposition. So it's clear why this is a revolution. The problem is that no one yet succeeded to build this kind of technology. Why is that? The success points we have today is, say, Waymo with robotaxi. The approach there is to invest in massive sensors. Right? If you go to the Waymo booth and you look at their vehicles, you see the amount of sensors, and these are tens of thousands of dollars of sensors. It is not, it's not appropriate for consumer car. Consumer car, it should be, the entire system should be a few thousands of dollars. Otherwise, there's no business.
Yeah.
So no one has showed how you can take a system with a few thousands of dollars of cost.
Affordable.
And so to make it affordable and reach the accuracy that you need for an eyes off. Now this accuracy is a discontinuity compared to the accuracy we have today. Today's system, the hands-off systems, even the best, the mean time between an intervention is few hours, 5 hours, 10 hours. Right?
Yeah.
The mean time between intervention you need for an eyes-off system ranges between tens of thousands of hours to millions of hours. So it's a huge barrier that you need to cross in order to go from an eyes on. So it's not a smooth transition. It's a discontinuity.
Yes.
And this is where Mobileye is targeting. This is where 90% of Mobileye's focus is on building this type of technology, because that will create a revolution. So we're starting with the chauffeur. In parallel, we're building also robotaxi. When we go through the booth, I'll show you also the robotaxi. This is with the Volkswagen on the ID Buzz platform. So both the chauffeur is really the first point in which you create a revolution. And this is 95% of Mobileye's focus is on building the technologies to reach that point.
From the starting point till the end of the vision, actually we see the AI, artificial intelligence, comes out. And now it becomes a really hot topic. It changes a lot of industries, ways of life, of work. So how Mobileye leverages the AI ability into the realization of all these things you just mentioned.
The AI changes in the past decade have been very, very meaningful. It changed everything. It started around 2012 with deep networks, allowed a developer to take raw images, to take the raw video and plug them into a network, and the network would find, for example, the vehicles in the sea. Right? Before the deep networks, a developer would need to find ways to detect features in the image, and then use machine learning to go from the features to the object. With deep networks, you can just feed in the raw images, the raw video, and you can have detections. But then you would need some ingenuity of taking the perception in the 2D images and lifting them up in 3D, and also integrating information from multiple cameras. The next jump was in 2017 with transformers. The building block of the ChatGPT, of all these language models. What has been done there is the ability to create a synchrony among very different types of fields. So before transformers, you need to have expertise in computer vision, a different expertise in natural language processing, a different expertise in voice or acoustic processing. Right? After transformers, it's all the same. Why it's all the same? Because what transformers do, they say, take your source of input and translate it into words. It's called tokens. And then you have a machine that goes token by token. It's called autoregressive. You have a number of tokens, and then you predict what is the next token. And then take your output and also translate it into tokens. Right? And then this machine goes from input tokens to output tokens. And the machine doesn't care if the tokens are coming from images, or the tokens are coming from language, or the tokens are coming from sound.
Whatever
Machine
the
doesn't care,
resources.
whatever.
Yeah.
So all of a sudden, all these different disciplines merged into one discipline. That was a big breakthrough. What it allowed in terms of our field is to take the raw images and images from different cameras and create directly the 3D perception. So place the car in 3D directly and not go through the 2D and then glue things together and build the 3D person. So it created a huge accelerant of the ability to process images. So this was a big change. And what we are doing at Mobileye is we're leveraging all these transformers in our next generation chip, the IQ6 that's coming out, but in a way that is very, very efficient and also enables us to reach the very high accuracy. What do I mean? If you look at AI systems today, take for example ChatGPT, right? Their optimization is not on precision. Their optimization is on availability. So if you look from GPT-3 to O1 and so forth, what has changed is that the language model can solve more and more problems.
Yes.
Right? But the accuracy hasn't improved much. Accuracy meaning you ask a question, do you get the correct answer or not?
Answer.
Right? It can hallucinate, it can give you wrong answers. Right? So the optimization is on availability and not on precision. When you want to go to an eyes-off autonomous car, what you want to optimize is precision. And this is where just a data-driven engine becomes problematic. So if all what you are doing, say I take only cameras, and I just train by feeding more and more data. The question is, can I get this very, very high precision? No one has been able to answer this yet. Right? Machine learning systems are not optimizing precision. They're optimizing availability. So you need to do something else. So that something else that we are doing is inspired from aviation. So aviation are airplanes.
Okay.
An airplane is an example of a machine that has to have very, very high precision, right? An airplane doesn't all of a sudden fall from the sky.
No, that's acceptable.
So how do they do that? They create redundancies. Every function is being implemented by multiple subsystems doing the same thing. And that gives a multiplication.
Yeah.
So if you take the failure rate of one system, and now if you have two systems with the same failure rate, now the failure rate is now square. So you're kind of multiplying. So you can get very, very quickly by doing multiple subsystems to a very, very high accuracy. So the question that we at Mobileye started to work on is how do we create these subsystems in order to boost precision? So we said, okay, in addition to cameras, we need to go and develop another sensor, which would be as good as cameras, but very different from cameras. So we started to develop imaging radars. So these are radars that are HD. They're very high resolution. They give you an output just like cameras, but they're very different. Right? They can work at any weather condition. Their failure points are very, very different from the failure points of cameras. So you get this independence. So now you have two subsystems, one from the imaging radars, the other from the cameras. In addition, we started to design additional subsystems within the software. So for example, we can think of a map as a sensor, and what the camera sees as another sensor. And now you have two separate informations that you can fuse together.
Combine them
together and create redundancies. So it's all about how you take the problem and break it down to multiple subsystems in order to boost up the precision. Because this is the name of the game. If you don't reach that level of very high precision, you cannot build a system which is eyes off. You'll stay with eyes on, which is a nice product, but that's not a revolution. Revolution is when you allow the driver to do something else.
Okay.
work on your smartphone, go to sleep maybe, right? But you don't need to pay attention to the road. This is the biggest challenge.
So when we enter the AI era, for the company's competition, it becomes harder or easier?
So to answer this question, let's go back to language models.
Okay.
Right? There are many companies building language models. So, the top ones are OpenAI, Anthropic, Google with their Gemini, but there are more than 100 companies.
Long tails.
Long tail. Now, there is a site called the Chatbot Arena.
Chatbot Arena.
Right? And what Chatbot Arena does, they rank all the language models, but they rank them not through passing benchmarks, because all these benchmarks are biased today, right? You cannot rely on declarations of passing a benchmark, because those systems are trained on the entire internet, they're trained also on the benchmarks, right? It's very difficult, right? So what they do crowdsourcing. So when a person asks a question, he gets two different answers from two different language models, and he needs to rank which is better. And in that way, they can rank all the language models. So of course, OpenAI is at the top, Anthropic is at the top. But then you have a long tail. So being in the middle of the pack, is easier today than it was 5 years ago, let's say. But being in the middle of the pack doesn't give you much.
Yes.
Because 99% of the usage are from the top two. So the same thing in our field. Building a vehicle with a nice performance as a demo vehicle is now easier today than it was 5 years ago.
Yes.
But going from a demo vehicle to a volume production on multiple car models, multiple OEMs, car makers, is a huge step up. Or building a vehicle that drives half an hour or 1 hour without a takeover is one thing. Building a vehicle that require 1 million hours to do a takeover is a completely different thing. So being at the top of the pack remains very difficult. Being at the middle of the pack is now easier than it was 5 years ago.
Mean nothing. I think in the middle or below the middle mean nothing at all.
Mean nothing, that's right.
What's the advantage of Mobileye? I mean, to keep on the top of the name?
It's multiple things. People think only about the AI or the software. It's way more than that. First, the silicon. The chip. Our chip is super efficient and very low cost. So it allows us to build systems at very affordable prices. Right? The chip is also designed to run the type of AI stack that we build. So this is one advantage. Second advantage, I'm putting aside AI for a moment. I'm talking about things that are outside of AI. Another advantage is we have a technique of building high-definition maps through crowdsourcing. So for example, most of Europe, most of the US is completely mapped through our technology of crowdsourcing. A third advantage is data. We have 650 petabytes of data.
That's huge.
Huge. Out of them, 300 petabytes are videos. So we're talking about tens of millions of hours of recorded video data all over the world. Now, all over the world is important because if you collect a lot of data in one geography, then it's not clear that if you now drive in another geography, it will drive the same, right?
Maybe it doesn't work.
It could be out of distribution. So you need data that is really covering the entire planet. Right? And this is one of the strengths of Mobileye. Out of this 25 years of working in the field, we acquired a lot of data. Then we have huge infrastructures, ways of accessing the data. Say for example, you find a edge case, even you describe it verbally. Say it could be a car upside down on the road. We have techniques, search engines. You type verbally a car upside down the road. It goes through our entire 650 petabytes of data and brings you back the pictures of car upside the road. And we use that to kind of continue and improve the system. We have extensive simulators. We have extensive hardware in the loop to allow the system to run through 10,000 hours of data overnight. Overnight. So
wow.
it's thousands of systems running together. So it's a big execution machine. Mobileye has delivered 190 million chips over the year. So 190 million cars in the world are driving with Mobileye technology. I think this is 15% of all the cars in the world.
Yeah.
It's amazing. More than 1,200 car models are using the Mobileye chip. So all of this gives a lot of experience, of know-how. Before talking about AI, Mobileye is an execution machine, right? And execution machine means that you can bring the best technology at the best cost. Because cost matters. If you bring very good technology but at a high cost, you are limited in volumes, right?
Yeah.
If you bring something very low cost but not high technology, you're also limited, limited in use cases. Mobileye is good at both, very, very high quality and very low cost. Then AI is our expertise. Now, I'm a professor of computer science. My expertise is artificial intelligence.
Now he's professor.
Yeah, I've been professor since 20 years. My colleague, who is the CTO of Mobileye, Shai Shalev-Schwartz, is also professor of computer science, professor of AI. I co-founded a number of companies in AI, both in robotics, Mentir robotics, humanoids, and language models, AI 21. I just launched another company, Double AI, now working on the AI of the next generation AI, kind of an AI that should replace, expertise like Newton and Einstein. How do you build an AI that can solve problems that only Einstein can solve? So this is another area that I'm looking into. So AI is really our DNA. So now put everything together, and you see that Mobileye is a very unique company.
Yes. We see the new technology actually are emerging at our times. If you look forward 10 years, let's say the future 10 years of Mobileye, what's your strategy for that?
So the vision of Mobileye is to first solve this problem of eyes off at an affordable price, right? So a few thousands of dollars, right? Starting with highways and then progressing into more types of roads, then progressing to no driver at all in the car at a consumer car level, but not robotaxi, consumer car level. So the first revolution is eyes off. The second revolution is no driver in the car. What does that mean? It means, a family can have just one car. Well, I take the car, drive it to work, and then send it back home.
By itself?
By itself, because no driver.
Autonomous driving.
Yeah, autonomous driving. So that's another revolution because it changes the ownership, the way we own cars today. You need much fewer cars to own in order to get the same level of transportation. So this is, I believe that will be closer to the end of the decade, 6-7 years from now.
Wow.
So in 2-3 years, it's the first eyes off, then progressing year after year with more and more availability until the point at which you can remove the driver in a consumer car.
In next 5 years, let's say.
5, 7, 8, kind of. That's
coming soon.
Really?
Coming soon.
Coming soon, yeah. So anything up to 10 years is coming soon in our business. Then I believe Mobileye should expand to additional areas where AI is in the physical world, like in robotics. Right? So I see Mobileye being the company doing AI in the real world. I think the nice name I heard, Jensen Huang gave a keynote, and he called this physical AI. Yeah, physical AI. So what I envision Mobileye is to be the company in volume production of physical AI.
Not only in automotive anymore.
Not only in automotive. But first, let's solve automotive and then expand.
Yeah. When we talk about intelligent driving currently, we see a lot of companies apply the end-to-end technology. What's your point on this field?
Okay. There's lots of rhetoric around this, and I think this rhetoric doesn't mean much. So even a company that says I'm doing end-to-end, they do more than end-to-end. So what would be end-to-end? End-to-end would be you take your, let's assume that we have only cameras. You take your video information as input, and output would be the control commands. We do that as well. In the talk that I gave yesterday, the press conference, I showed one of Mobileye's streams, which is an end-to-end, starting from images, going to control. What differs Mobileye from others who talk about end-to-end, their rhetoric is, all what you need is only end-to-end. What Mobileye says is you need redundancies. It's not enough just end-to-end. You need additional paths in order to create subsystems. It's not only the different sensors, but also different algorithms. So end-to-end is just one path. There are additional paths. And we call that compound AI system. So Mobileye's approach is end-to-end is one component in a compound AI system.
Okay, so that's different sorts, not more than end-to-end actually.
Yeah, so it's end-to-end is one element, one piece, but then other pieces.
When we talk about the autonomous driving, we see that many manufacturers are competing on the computing power. Is that higher better, or actually there is another way to solve the problem?
So computing power is a necessary condition because the kinds of technologies AI offers today require increasing computing power. Yeah. The question is, how do you measure computing power? So the standard measurement is tera operations per second, called TOPS. Mobileye claims this is the wrong measure.
It's wrong.
It's the wrong measure. There should be other measures that measure the efficiency of the chip. So Mobileye measures frames per second. So take a certain algorithm. How many frames per second running this particular algorithm you can get with your chip? So for example, what we show that the difference between IQ5 and IQ6, in TOPS, it's only twice. In frames per second, it's 10 times.
Wow, it's 10 times.
10 times. So there's a huge gap between measuring TOPS and measuring frames per second. What matters is the frames per second, because this is this is the real output that you want to get out of the chip. I have an algorithm. How fast can I run this algorithm? I don't care about TOPS, because the chip itself has multiple accelerators. It's not just a CPU, not just a GPU. There's additional accelerators. And this additional accelerator, even in our competitor chips like NVIDIA's and so forth, there are multiple types of accelerators, not just GPUs. Therefore, measuring TOPS is trying to put everything in one basket. But each accelerator has a sweet spot of what kind of workloads it can run. So the best way to measure this is frames per second. And this is how Mobileye measures efficiency of a chip. And our chip, the IQ6, is strong enough with a number of chips to run all the autonomy that we need. So we are ranging from one IQ6 for a system, we call it surround ADAS, front-facing camera, 4 parking cameras, and surround radars. One IQ6.
One IQ6.
2 IQ6 is for the supervision, 11 cameras around the car and few radars as option. 3 IQ6 is the chauffeur, the eyes-off system. 4 IQ6 is the robotaxi. In 2027, IQ6 is being replaced by IQ7. IQ7 would have more efficiency. So system that had 2 IQ6 will have 1 IQ7. System that had 4 IQ6 would have 2 IQ7. And that's, again, to do cost reduction.
Yeah, cost reduction. That's what customer wanted.
At the end of the day, it's a optimization of cost and performance.
Yeah.
And you need to optimize both. You cannot just focus on one end.
Last year, you visited China. Have you ever tried the Chinese EV by yourself in person?
The Chinese systems of hands-off, eyes-on are very, very impressive. Extremely impressive. They are more expensive. They use more compute, they use more sensors, but in terms of performance, they're very, very impressive.
Now, more and more Chinese OEM, they want to go globally. What kind of challenge you think they will face, and any suggestions or anything Mobileye can help them in overseas market?
So most of our customers in China, the Chinese OEMs, are OEMs that have global aspirations. And actually, this year we are going to have about 40% growth in China in terms of our ADAS offering. And this is exactly those OEMs that have global, like Chery, like Geely, they have global expansions. And the advantage of Mobileye is that our system works all over the globe. So you don't need to go and start collecting data from every country that you want to deploy. And this is, we see that sustainable and even growing in China to work with customers that have this global expansion.
When we talk about the autonomous driving, actually the pace of development and the scenario situation is quite different in different countries and regions. From your point of view, how can autonomous driving become true in certain areas, which will be the first place?
So this is where the maps become critical, these high definition maps. Because think of a map as a memory. Now, when you drive your car, if you are driving through an area that you have driven before, you feel much more comfortable and ease in driving. When you're driving in a new area, you are more focused, right? So because you don't have a memory of this place. So think of a map as memory. Having access to this memory allows you to expand globally much easier than if you are getting into a new place, first time you see it, new types of culture of driving, regulations. All of this can be taken away if you have this memory. So one of the key elements of scalability, geographic scalability, is being able to have map access all over the world.
That's the question I asked for the professor about the education and AI. Since the AI is developed so fast, I always think about how about the future of education, especially for the kids. What kind of things they should learn for the future?
Well, let's look at first the revolution of search, of Google, right? 20 years ago. So 20 years ago, people who had lots of factual memory were considered very smart, very intelligent.
Yeah.
Today, when you look at it, why do you need to remember so many facts? You simply Google it,
yes.
Right? I think the same thing, take it with steroids. What happens when you have AI? Mundane things, like take an article and summarize, or take a number of articles and create one big summary of all those articles, create a plan, or things like that can be automated. So now we need to think as humans, what can we do that the machines cannot do?
Yes.
Right? And this is what's going to distinguish between a successful human and a less successful human. Just like today, a successful human is not the one that has lots of factual memory, because everything is searchable.
They need correct.
Right? And AI will have its limitations. Right? I think AI would be a very good tool to help humans, to help productivity. Right? And humans that do not know how to use AI will be left back. So it's very important that at the education level, people learn how to use AI. It means that teachers need to work harder, right? Because you need to be able to think about assignments that are difficult for the students, even if they use AI. But you cannot assume that they'll not be using AI. So you need to give them assignments, knowing that they're using AI to solve the assignments, and it's still going to be difficult for them. So they need to put their effort into it. So the challenge of education is to have teachers that provide assignments that are more difficult than today.
That's harder.
That's harder.
Yeah, that's hard.
the challenge.
Okay.